Hi friends, this is our fifth lecture of units and measurement, and in the previous lectures we were discussing the uses of dimension. So we have completed the three uses of dimensions. Which were they? To check the correctness of an equation, first one. To convert a unit from one system to another system, second one. And to find the correct relation between the different physical quantities, the third one. Okay, and today we are going to discuss each example from each users once more. Okay, so we are today also going to discuss the uses of dimension once more. Okay, so what was the first use to check the correctness of an equation? Check the equation. The first question, check whether half mv square is equal to mgh. Whether half mv square is equal to mgh. This is the first question. So, how to check? Which was the principle we have used? Principle of homogeneity. Principle of homogeneity. And according to the principle of homogeneity, for an equation to correct, the dimensions on both sides of the equation must be same. Okay. If the dimensions on both sides are same, then the equation is dimensionally correct. So, we'll check whether this equation is correct. So, put the dimensions on LHS and RHS. Half. No dimension. Mass m. Velocity LT raised to minus 1. The whole square. Okay, solve it. So, we are discussing the LHS. It is equal to m L square T raised to minus 2. Okay. And now RHS. Taking RHS. mgh. M for mass. G, acceleration due to gravity, is also an acceleration. So what was the dimension of acceleration? L T raised to minus 2. And h is a length L. Taking m L square T raised to minus 2. So what about the dimensions on? The dimension of LHS is ml square T raised to minus 2. The dimension of RHS is ml square T raised to minus 2. It means that the equation given was dimensionally correct. Why this dimensionally correct? Because we never get any idea about this half. Whatever may be the number taken there, the dimension will be same. So, always refer it is dimensionally correct because it doesn't tell us about any number with the physical quantities taken. Okay. So, since now we can say the equation is, since the dimensions on both sides are same, the equation is dimensionally. The equation is dimensionally correct. Okay. Is it clear? So, this was the first use. We are going to second question where we are taking the second use. Okay, what was the second use? To convert a unit from a given system to another system. Okay, in the second question, it is given that gravitational constant G is equal to 6.67 into 10 raised to minus 11 Newton meter square kilogram raised to minus 2. It is given that gravitational constant G is equal to 6.67 into 10 raised to minus 11 Newton meter square kilogram square. Question is, find the value of G in CGS system. CGS system. You have to find the value of this gravitational constant G in CGS system. Okay. So the value of G is given as 6.67 into 10 raised to minus 11 Newton meter square kilogram raised to minus 2. So which system is given? Newton meter kilogram, that is SI system is given. You have to convert it into which system? CGS system. So how to convert this by using the dimension? At first, you have to write the dimension of the given quantity, dimension of G. Okay, so the unit was Newton meter square kilogram raised to minus 2. Okay, the unit was Newton meter square kilogram raised to minus 2. What is the dimension of Newton? Newton force. What is the unit? Newton is the unit of which physical quantity? Force. So Newton force, mass into acceleration, mlt raised to minus 2. Is it clear? Newton is the unit of force. Equation for force is F is equal to ma. M, capital M. Acceleration A, lt raised to minus 2. So Newton has a dimension of mlt raised to minus 2. Then meter square. Meter is a length, so L square. Kilogram raised to minus 2. Kilogram is a mass, so m raised to minus 2. Putting together m raised to minus 2. M raised to 1 into m raised to minus 2. M raised to 1 minus 2. M raised to minus 1. L into L square. L cube t raised to minus 2. So what is the dimension of the quantity gravitational constant? It is a constant. So but it has a dimension. It is not a quantity, but it is a constant here. But it has a dimension. What is the dimension of this gravitational constant? M raised to minus 1, L cube, t raised to minus 2. Okay. Now we get dimension. Now we have to convert it into which unit? CGS unit. So how we have taken that? We have written 6 point, how we have done that? 6.67 into 10 raised to minus 11. 11 into m1 raised to minus 1, L1 raised to 3, T1 raised to minus 2 is equal to x times. Okay. Have you remembered? X times m2 raised to minus 1, L2 raised to 3, T2 raised to minus 2. We want this x. We want this x. Okay. So this much is equal to x times in CGS. So x is equal to, how you write? 6.67 into 10 raised to minus 11 into m1 raised to minus 1, L1 cube, T1 raised to minus 2 divided by m2 raised to minus 1, L2 cube, T2 raised to minus 2. Okay. Now providing the units. Minus 11 into, this is in, the first one is in SI system. So 1 kilogram raised to minus 1 into 1 meter the whole cube into 1 second raised to minus 2. In SI system, mass has a unit of kilogram, length has a unit of mass, and time has a unit of second. Whereas in CGS system, M2, 1 gram raised to minus 1, 1 centimeter the whole raised to 3, 1 second raised to minus 2. This may be cancelled. Now, we have to convert from SI to CGS. So, convert this SI values. X is equal to 6.67 into 10 raised to minus 11 into 1 kilogram. X is equal to 6.67 into 10 raised to minus 11 into 1 kilogram. 1000 gram. We have to convert into gram raised to minus 1. 1 meter, 100 centimeter cube by 1 gram raised to minus 1, 1 centimeter cube. Is it clear? Is it clear? Now, in the next step, this is 1000 gram raised to minus 1. X raised to minus 1 means 1 by x. So 1000 raised to minus 1 means 1 by 1000. Is it clear? Is it clear? So in the next step, we will write like this. X is equal to 6.67 into 10 raised to minus 11 into 1 by 1000 gram. Is it clear? 1000 gram raised to minus 1 means 1 by 1000. 100 centimeter cube. 100 centimeter into 100 centimeter into 100 centimeter. Is it clear? So whether this is clear here? Okay. May I write from this? Okay, how to write? We will write here. So what was x is equal to 6 point, here also there is no space. So may I, hoping you have paused the video and you may write this. Okay, x is equal to 6.67 into 10 raised to minus 11 into 1000 gram raised to minus 1 means 1 by 1000 gram. Okay, and in denominator there is 1 gram raised to minus 1. 1 gram raised to minus 1 means it is equal to 1 by 1 gram. That is 1 by 1 gram. That is, it is on the denominator becomes 1 by 1 gram. It becomes on the numerator into 100 centimeter into 100 centimeter into 100 centimeter by 1 centimeter into 1 centimeter into 1 centimeter. Gram, gram. Centimeter, 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 centimeter. And in upward there is 1, 2, 3, 4, 5, 6. 3 zeros are cancelled. 1, 2, 3. 1, 2, 3. That is x becomes 6.67 into 10 raised to minus 11 into 10 raised to minus 3. Okay. So the value of x is equal to 6.67 into 10 raised to minus 8. Okay. So what is the value of g in CHS unit? In CHS unit, we will write in CHS, g will be equal to 6.67 into 10 raised to minus 8 with the proper units. How to write the unit? Newton becomes dynes, meter becomes centimeter square, gram becomes, kilogram becomes gram raised to minus 2. Okay, so this is the value of g in CHS unit. Okay, pause the video and do it. Then only you understood. Is it clear? Okay. So we have taken a question from this second use also. And now we are going to pause the video, write it 2 or 3 times, then only it becomes perfect to you. Newton is a SI unit of force. CHS system, force as a unit of dynes, which we have already studied. Okay, so this was the second question. So we have checked whether an equation is correct or wrong. We have converted a unit from a given system to another system. And what was the third use? To find the relation between different physical quantities. Okay, we are going to one of the question from it. Third question. A question is given like this. The speed of sound V in a medium, through a medium. The speed of sound through a medium depends on 1. Pressure P of the medium. Okay. 2. Pressure density D of the medium. And 3. Acceleration due to gravity. G. Okay. So the question is the speed of sound. I am talking, my sound is traveling. So the speed of sound depends on the pressure of this medium, the density of the medium, the acceleration due to gravity here. Okay. So we have to find, the question is find the relation. Find the relation. Okay. This is the question. Find the relation. So how we find it? Okay, we are going to do it. We will write pressure P we want the relation of velocity. Velocity of sound, the speed of sound V depends on P raised to X density d raised to y, and acceleration due to gravity is z. Okay. In the next step, we will convert it into an equation. Then only we apply principle of homogeneity. So, a constant k into p raised to x, d raised to y, and g raised to z. Providing dimensions on both sides. What is the dimension of velocity? Lt raised to minus 1. Completely m0, L1. It is Lt raised to minus 1, put m0 is equal to, k is a constant, no dimension. Now we want pressure. Do you remember what is the dimension of pressure? Pressure is equal to force by area, mass into acceleration by length into breadth, m Lt raised to minus 2 by LL. Length and breadth both are length. LL on cancelling. Pressure becomes m L raised to minus 1, T raised to minus 2. Similarly, what about density? Mass by volume. So we will get m by L cube. M L raised to minus 3. Providing. Is it clear? We have already discussed these dimensions. So pressure K has no dimension, pressure m L raised to minus 1, T raised to minus 2. The whole raised to x. What about density? M L raised to minus 3, the whole raised to 1. And acceleration due to gravity is an acceleration. So Lt raised to minus 2, the whole raised to z. Okay. Once more writing, m0, L1, T1 is equal to, expand m raised to x, L raised to minus x, T raised to minus 2x. M raised to y, L raised to minus 3y. L raised to z, T raised to minus 2z. Okay. Once more. Do you understood? Write this. Okay. Okay. Is it clear? L1, T1. Oh, T raised to minus 1. Okay. Is equal to, this is minus 1. M raised to x, M raised to y. You will write it as x plus y. L raised to minus x, minus 3y and z. L raised to minus x, minus 3y plus z. Is it clear? L raised to minus x, L raised to minus 3y, L raised to z. So L raised to minus x, minus 3y plus z. And T raised to minus 2x here, minus 2z here. Okay. So this is the equation we obtained now. Now we have to solve this. According to the principle of homogeneity, m raised to 0 on LHS will be equal to m raised to x plus y on the RHS. Or we can write x plus y is equal to 0. Okay. Next, L raised to 1 on the LHS is equal to L raised to minus x minus 3y plus z. Or we can write minus x minus 3y plus z is equal to 1. Is it clear? And in the next step, t raised to minus 1 is equal to t raised to minus 2x minus 2z. Minus 2x minus 2z is equal to minus 1. All of them are minus. So multiplying again with the minus, we will get 2x plus 2z is equal to 1. Okay. Then how we solve this? All of the equations will have two variables. So how to solve? Simplify it. You know it in your maths how to do. So from here we can write, here there is x and z. X and z. So here we can write y as minus x. Is it clear? Y is equal to minus x. So it is correct. Providing the value of y here, putting this value here, minus x minus 3 into y becomes minus x again plus z is equal to 1. Okay. Then minus x minus of minus plus 3x plus z is equal to 1. Minus x plus 3x, 2x plus z is equal to 1. Or we can write 2x, whether you see this. Here we can write, where? Here. Now 2x is equal to 1 minus z. Whether it is clear to you? Okay. After this, we can write here, or 2x is equal to 1 minus z. Is it clear? 2x plus z is equal to 1. So 2x is equal to 1 minus z. Okay. Okay, is it clear? Just write it. Then it becomes perfect to you. 1 minus. So value of 2x is 1 minus z. Put here 1 minus z to this equation. Plus 2z is equal to 1. 1 plus z. 1 minus z plus 2z. 2 minus 1. 1 z is equal to 1. Z is equal to 0. Okay. So what is the value of z? 0. If z is 0, what is 2x? 2x is equal to, here we can write in next ink. So it become perfect once more. So z is equal to 0. And providing the value of z here, 2x is equal to 1 minus 0, 2x is equal to 1, or x is equal to 1 by 2. Clear? Clear? X is equal to 1 by 2. If x is equal to 1 by 2, y is equal to minus 1 by 2. Okay, pause the video. Try to do it. Then it becomes perfect. Simple maths. Okay, how to solve 2 or 3 variables together. Okay, I have written everything here. Just you have to pause the video, try to write it, copy it, then you become perfect what I am writing. Okay, just mathematical calculation. So we get the values of x, y and z. Now, which was our basic equation? Our basic equation was this. This is the first equation. So providing the value of x, y, z in this equation, we will write. Now, the speed of my sound through this medium depends on v is proportional to p raised to x, p raised to x, p raised to half, x value is half, d raised to y, d raised to y, density raised to minus half. Okay, and g raised to z, z value, yeah, here, z. Oh, g raised to 0. What is g raised to 0? What is x raised to 0? 1. So what is g raised to 0? Again 1. That means g has no dependence. The speed is independent of acceleration due to gravity. It doesn't depend. They have told us the speed of sound, my sound, depends on g, acceleration due to gravity. Here, no. The speed doesn't depend on g. We have proved it. All okay. Now, p raised to, what is x raised to half means? X raised to half means root x. Minus half means 1 by root x. So, you can write this as v is proportional to root of p by d. Raised to half. X raised to half means root x. Okay, so p raised to half means root p. D raised to half means root d. But minus half means in denominator. So, what is the value or what is the relation of velocity with the pressure, density and acceleration due to gravity? How my speed of this sound wave depends on the pressure here, the density of air here and acceleration due to gravity here. Yes, it depends upon the speed of sound, it depends upon pressure and density, but it is independent of acceleration due to gravity. We have proved it. We have proved that the speed of sound through a medium is independent of acceleration due to gravity and depends on pressure and d, like this, v proportional to root p by d by using our dimension. So, we have completed the 3 uses of dimensions. I'm hoping you are very well with the uses of dimension now. Okay, is it clear? So, today we are writing this video. Try to pause the video and do the problems. This is not a problem, but a simple calculation. Okay, do it very well. Till the next video. Okay, see you. Have a nice days. And before winding up, just introducing once more, this is our channel, Physics Gallery. Okay, see you.